Hi everyone, welcome back to my channel. So far we have looked at the future value of money, compounding effect of money, CAGR, and some real world examples. So the next practical question to ask is how long will I take to get to where I want to be at? Be it 50k, the first 100k invested, 200k, 1 million, or whatever. Okay, we can actually plan and track ourselves. So how do I actually map my path to say the first 100k? So actually this is also a mathematical model that we can actually model it with to actually help us set our pace and make realistic goals. So in using this arithmetic progression to actually set my pace, it actually allows you to check whether what you have planned for is feasible or impossible. Okay, so if your financial goal is impossible or mathematically unfeasible, for example, you start with $10,000 in your account and then you want to save 5,000 per month. Okay, this is unfeasible. Okay, but you can also ask yourself, okay, I want to get to 100k in 5 years, right? It's also quite impossible because that would actually mean that you have to save quite a lot of money, okay, every month. So we can either work forward or work backwards to know how long or how much I need to have to save in order to reach my goals. So abstract goals without a timeline are actually quite dangerous because you may not know whether you're on the right track. Okay, so in order to help us get to our goal, having a plan, having a structured contribution, okay, will help us to not just structure ourselves. Okay, it also keep us disciplined in trying to reach our goal. Okay, so this arithmetic progression model actually help us to um, take some sort of like help us to make sure, okay, we are on the right track and we are on the way to where we want to be. Okay, so let's say I want to structure, okay, $10,000 investment plan, okay, or as in this plan is not like I'm going to sell an insurance plan, that kind of plan, but it's that I want to save 100k. How long will it take? Or I want to invest 100k. How long will it take? If it's just saving, okay, the question is actually quite straightforward. But if you are talking about investing, whether it's investing 100k or reaching 100k in value, that's another question to be answered, okay, in the second part of this series, as in this video on arithmetic progression. Okay, so we will just look at the simple goal of saving 100k or investing 100k. Okay, so we, for example, start with a base contribution of $500 per month. Okay, so I tell myself I'm going to save $500 per month, and then in a year I'm going to save 6,000. And then I know that, okay, when I work I will get PB, I will get merit increment. It's about maybe 300 or $200 per month of merit increment, and 100 of that goes into increasing my investment or savings. So that's $100 per month extra per year. So that's $1,200 per year extra in increment. So how long does it take for the total invested amount, okay, that I save to hit exactly 10,000, 100,000, or actually more than 100,000? Okay, usually it won't be exactly. Okay, you will either fall short by a bit or you overshoot if we are talking about year. Okay, but of course if you talk about months, then maybe yes, you are going to have a little more exact value, but that's fine. So before that, let us first look at this question from a mathematical point of view. Okay, so I start with a base amount. Okay, I call that the first term. okay? And then I'm going to do this based on a yearly basis. So every year, okay, annual increment, okay, will be my common difference. Okay, why is it called common difference? Because year on year, I'm just going to invest 1,200 more. No more, no less. If let's say you are to vary this annual increment because of whatever reasons, okay, then of course the calculation will deviate, but that's fine. Okay, we take it as a disciplined approach. We will only do the same annual increment every year. So this means that, okay, if I say that this is represented by A and this is represented by D, that means in year 1, I start with A, okay, A amount. In year number 2, disregarding investment, interest, bank interest, growth or whatever, the next year I'm just going to put in A plus D more, right? So the first year I start with 6,000. The second year it will be 6,000 plus $1,002, which is 7,200. In my year number 3, I will have what I have at the end of year 2 plus another annual increment of 1,002, which now gives us 6,000 plus 1,002, add another 1,002. Okay, the reason why I do not want to add up the numbers now, okay, is because I want to be able to see a pattern. Okay, this actually simplifies to A plus 2D. So you will be able to see in year number 4, I will have A plus 2D plus another D, which gives me A plus 3D. So if I keep on going on at year n, okay, I will get A plus n minus 1D. So what this tells me is that I have a very structured way of knowing, okay, year on year how much I'm putting in and what is that final amount using a generic formula. So this whole thing is called an arithmetic progression. Okay, so in this arithmetic progression, I must have a first term A and a common difference D. Okay, so that is very good for us, because if I have such a structured model, okay, I can actually try and find what happens when I add up all my terms. So in mathematics, we call this the SN, which is the sum of first n terms. Okay, so to find the sum of first n terms of an AP, okay, I relate it back to a story, okay, by the famous mathematician Gauss. When he was young, he was actually given a task in class to calculate the sum of 1 plus 2 plus 3 plus 4 all the way to 100. Okay, so his teacher was thinking that that will give him a lot of rest time in class, since it would actually take quite some time to do it. But Gauss actually had a brilliant idea where he flipped the sum over uh, 4, 3, 2, 1, okay, to see that I have all of them adding up to 101 when I do this pairing. And then he had exactly 100 pairs of them. So when I add the two sums together, I have 2 times the sum that I needed to be 100 pairs of 101, which gives me 100 over 2 times 101, which is 5050, and he did it in under a minute. So if I use this idea, you will be able to see that actually this 1 plus 2 plus 3 plus 4 is actually an AP, with the first term being A and the common difference being 1. So I can make use of this idea similarly on our AP. So I have A followed by A plus 2D, A plus D, sorry, A plus 2D, all the way to A plus n minus 2D plus A plus n minus 1D. So what we need to do is to flip this around, plus A plus n minus 2D plus A plus D at A. So what we will realize is that we have n pairs of 2A plus n minus 1D. Right? So this tells us that 2 times of our sum, Sn, is equals to n times 2A plus n minus 1D. So Sn equals to n over 2, 2A plus n minus 1D. So this is our sum of first n terms of our AP. Now, with this, we will be able to plug the numbers into our formula and actually get our number of years that we want. Okay, so the strategy being translated into AP is as such. My first term of my starting point, which is $500 per month, so I put in 6,000 one shot at the start of the year, is fine. And then my common difference is $100 a month, 1,002 a year. That's my yearly increment. Okay, and then I want the total sum to be 100K or whatever amount that I want. Okay, so using this as my formula by plugging the numbers into the formula. Okay, n over 2 6,000 plus n minus 1,002. So 100,000 equals to n 6,000 plus, okay, this is 600, so 600 n minus 600. So I will get 100,000 n 600 n plus 5,400, which I can divide by 200 on both sides. So if I divide by 200 on both sides, I will get 500 equals to n times 3n at 27. So this reduces to 3n squared plus 27n minus 500 equals to 0. So what we know is that this is a quadratic in n. Okay, according to our O-level syllabus, we will know that n equals to negative b. Okay, for any quadratic equation, an squared plus bn plus c equals to 0, where my a is non-zero, my n is equals to negative b plus minus square root b squared minus 4ac over 2a. Okay, so what will happen is I plug it in, I reduce it to this quadratic state, and subbing my a as 3, my b as 27, and my c as negative 500, okay, I will be able to get that I have either n to be negative 18 or exactly equals to 9. However, time cannot be years cannot be negative, so I'm going to reject this number, and I'm only left with the answer 9. So this means if I were to follow this exact structure, it will take me 9 years to reach 100k saved or invested. Okay, so how do I actually get the universal timeline? Okay, depending on your A and D, up to you, your comfort level. How do we actually get this formula? We're going to derive it step by step. So A is my comfortable starting amount, which you can start now. D is your planned yearly increment that you want, and T is my total target investment goal. So plugging it into our AP formula gives us T equals to n over 2, 2a plus n minus 1d. Right? So what I'm going to do is I'm just going to reduce it into a quadratic. So I multiply 2 on both sides. I have 2 plus n d minus d. So 2t equals to n d plus 2a minus d. Okay? And I have n square d plus 2a minus d, and minus 2t is equals to 0. So this is exactly the quadratic that I need, and using the quadratic formula with a equal first term to be d, not first term, sorry, a to be d, b to be 2a minus d, and c to be negative 2t, I will get n equals to minus 2a minus d plus minus square root b square minus 4d negative 2t divided by 2d. Now, do note that I have to reject the negative values. So this one, actually, I just need to retain the plus. And my final answer is negative 2a minus d plus square root 2a minus d square at 8 dt divided by 2d. So based on this formula, if you know what is the a and the d and the t that you want, you will be able to get the number of years to reach your target. So you can see that maths sets the pace, but discipline helps you to cross the finishing line. Okay, so this mathematical progression is perfectly predictable, but executing it is entirely your human nature. Okay, so to make this mathematical timeline a reality, you need to be disciplined and you follow the rules strictly to stay invested and make your savings grow. So in the next video, I'm going to look at another progression that actually helps us to know how long does it take for my investment to grow to the value that I want. Thanks for watching. If you like my content, please like, share and comment, and then subscribe to the channel as well. If you have any maths problems or any daily situations that you would like to see how maths can be used to solve them, do let me know as well. Thank you.